Zoom, zoom, get them. You have two functions. You're supposed to do 2 to 3 different things with them. Don't miss the bottom corner. Also find their domains. Multiply, divide, compose, and find domains. Who's still rolling? Okay. Then, F does this stuff. G does this stuff. And what? There we go. So, round one, F times G. Just take the F rule times the G rule. Getting x cubed, 3x squared, minus 10x, and then a negative 2. X squared, a negative 6x, and a positive 20 for a grand total of x cubed plus x squared minus 16x plus 20. Domain. If it's polynomial, by definition, all real numbers. When I'm just multiplying or dividing, all I got to do is look at what I did. I don't have to worry about any input functions because I'm not putting a function in. So, everybody's allowed to that party. Question 2, incorrect. Factor the numerator. Numerator happens to have a factor in common with the denominator. They cancel out. Now, we have this here to be careful. X plus 5 may be the final result, but who's still not allowed to the party? Okay. Get him out of here. Negative infinity to 2, can't touch this. And 2 to infinity. Okay, 2 is still not allowed. Even though it canceled out, even though my end result is just a line, we have to remember there's a hole on that line at 2 because of the removable factor. That's where that removable discontinuity stuff came in. And round 3 was a composition. F says square a thing, triple a thing, subtract 10. That thing will be x minus 2. Square, not like a freshman. Distribute, minus 10. For a grand total of x squared, minus 4 minus x, 4 minus 6, negative 2, negative 12. Now, you can factor that. Just because you can factor something doesn't mean you should. Okay? Just because you can do the thing doesn't mean you should. In this case, I just have a polynomial. That's my answer, standard form. And everybody's allowed to the after party, everybody's allowed to the before party. So, there are no restrictions to either the output or input functions. All real numbers. Did you get the rule, get the rule, get the rule, get the domain, and since those were both just all real numbers, we'll put those two together. Yes, ma'am?
So if there's not like the middle one where you can't have two, so then you do the domain like that, is it always going to be all reals? Like if it looks like the first and third?
Oh, polynomials will always have a domain of all real numbers. That's part of their definition. When we review them again, section, I want to say 2.1, when we hit, y'all remember chapter 5 from Algebra 2? Like the big kahuna where you learned about cubics and quartics and complex roots and all that kind of stuff. Okay, we're going to review that sections like 1 through 4 and just kind of crank it up. We talk about that definition again because a polynomial doesn't have a radical in it. It doesn't have a logarithm in it. It doesn't have a variable on denominator. A polynomial doesn't have any of the things that can break math law. So they have all real numbers. The only time we got to watch out is those. Rational functions, they have problems. Okay? Nothing else? Okay. All right. This goes away. That I remember, only received a couple of questions from a person, or, well, people that look the same. But what we got? Okay. Some pretty common questions were, because we had some questions last hour too. If I have f of g of h, do them backwards. H into g, whatever that result is, into f. You always work it backwards up the chain. Remember, it's like that, the shark eating the big fish, eating the little fish, eating the worm. You have to put one into the other backwards up the chain. Did we do okay with this one? It was like find f of g of number. We'll find g of number, plug that into f. It's just you're using a graph instead of equations. Number 60-something? 61 was... Oh, 65. Okay. 65 said f of g of -4. So f of g of -4 says, go find g of -4. Was it 4 or -4? Okay. So if I go plug in -4, was it? Oh, is there a different graph for it?
Maybe not.
65. Use this graph. Okay.
Logical guess.
Sounds more like we're just spitting out words. Yeah. G of -4. When I plug -4 into the g function, I get -4. So if g of -4 is -4, stick a -4 into f. -4 in the f function, 0. Chain it together. Okay? So the graph one was asked, the f of g of h thing was asked. I don't remember too much more than that. It was really about the notation, less about the math, more about the notation. Which is why I just had to spend 2.5 days on function notation with my algebra half class. Because they can't get it through their head that w of x means put a x in. They're having trouble. They're having trouble. Freshmen, abstract concept, not so good. But nothing? Alright. Cool beans. Review. 1, 2, 3, 4. Womp. 1, 2, 3. Okay, a reminder that I had to share with first hour. I'll say it again here. Y'all, I am not the gotcha guy. I'm not the follow the rule or else die guy. I'm the let's have a conversation guy. If you come in on quiz day and you're like, This weekend sucked. Like, I ain't gonna get into it, but this weekend really sucked. Can I just take a mental health class and just kind of chill right now and come back and do it like on Tuesday or Wednesday? All right, we can do that. You say, I missed Thursday and Friday. I don't feel ready for this. Okay, try to get it done this week so that I can put it in for midterms. Other than that, I get it. Stuff happens. So hang out for review day, follow along with review day, and then take it when you are ready, if that is the case. All right? You shouldn't be forced to do thing on bad day, which is also why standardized tests are kind of trash. Because what happens if you just have a really bad day on Saturday and that was your ACT? Oh well, right? Not very fair. So I want to make sure that as we're doing this, if you feel like you ain't ready, then tell me. Have a conversation. So, we'll start with, we did the very, very, very end of 1.3, which I think we already covered as just the continuity symmetry stuff. So starting at 1.4 was extrema and rate of change. If I'm trying to find extrema and rate of change, where am I headed first? Calculatron. Boop, 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 boop. I plug thing in. Right? Yeah. So that's still there from last hour. I plug that in. Hey, what if my window is all messed up because the last time I was using my calculator, I was doing a word problem with like big giant numbers in it. Okay. If I want just my window to go back to a normal 10 in every direction grid, that's called the standard grid. So zoom standard is a good way to get back to this. Now sometimes it still don't see what you need to and you need to adjust it. That's fine. Okay. What is extrema? Relative or absolute
Like maximum.
maximums and minimums. How many extrema does this have?
One. Four.
One. It doesn't switch directions.
No, four.
It goes
No,
forward.
one.
No, four. I was getting four at all.
Four. I don't know. Two.
It depends. Do you count positive infinity? Do you count both of those?
Okay, there we go. Now we're having the conversation. Who said 4? Why do you think? Go. Did we count plus or minus infinity as extrema?
No. Because it's not relative.
Okay. Can anyone tell me what is extrema?
It is the rate of change, or where the rate of change, the rate of,
Not the rate of, wouldn't it be just the
Turning points.
Yeah.
Say it nice and simple, it's the turning points. It's where the function switches from an increasing to an decreasing interval, or vice versa. So this only has one extrema, because it only has one place where it actually switched direction. Now, I can confirm that because maybe we're a little scared that maybe this comes down below the axis and back up. Because if it does, then there's also some extrema there, and they're just really tiny. So I could zoom in on that point. I could zoom in on that point just to double check things. Okay, it's starting to look a little better. All right, so I'm pretty confident at this point that there's not a little Humpty Dumpty right there, okay? So what is that called? Point of inflection. Remember, point of inflection is where the rate of change is changing. but the increase-decrease doesn't. Case in point, coming into town this morning, I saw flashing lights. Boy, were highway patrol, they were busy this morning. Okay, my kid was just excited as all hell because flashing lights, there's someone, he pulled him over. He thought it was hilarious whenever he sees someone get pulled over. So, yeah, I do. He deserved it. Okay. I may hit the brakes and slow down, like, oh crap, are those lights for me? And then I let off the brake as he goes by. And then I hit the brakes some more when I see the next cop about 300 yards down the road. The rate of my deceleration changed, but I was still decelerating the entire time. I never put my foot back on the gas. Okay. So I only have one extrema, not format, calculate, a minimum, and it appears to be somewhere between here and 6. I don't care. So make a note to yourself. Point of inflection is not extrema. Don't label it. Okay. Looks like I got a little bit of round off error again. Here I'm going to say that I have a what kind of minimum?
Absolute.
I have a maximum minimum. What? It is an absolute minimum. The maximum minimum. I have an absolute minimum approximately. I am going to turn this, it's that little itty bitty round off error, I'm going to turn that into 5/4. Negative 8.543. If you just called it 1.25, that's fine as well, because it is terminating decimal. It's an absolute because it's the lowest it ever goes. How do I know that this is actually the lowest? How do I know that there isn't a continuation of the graph back here off screen?
Because it's
You just have to.
just
Oh,
now.
look at the equation.
Look, okay, now we're getting better. Look at the equation, look at the graph. Remember your training, young Jedi. X to the 4th. Okay, I've got 4 zeros. Leading term test. If it's a positive even polynomial, remember all the limit as I approach positive or negative infinity? Either it's an odd positive, it's an odd negative, it's a even positive, it's an even negative. You never seen little stick figure dances? I used to have the shirt and then I burnt a hole on it. So. I burn things. So yes, there is only the one. I know that I see all the zeros. Also, does anyone remember that behaved like a cubic? So it's x plus 1 cubed right there, because it behaves like a cubic at that 0. Multiplicity of zeros. It behaves like a line, so it's x minus 2 happening to the first power. Altogether, I have 4 zeros, so I've seen my entire graph. Okay, we'll review all of this in the first half of chapter 2. So, I've got my absolute minimum, and that's it. Locate and classify. What are some notes that you can write to yourself so you don't get the little points off? Use approximate symbol if it isn't a terminating decimal. Go 3 places. Don't eyeball it. Find it for real. Just because it looks kind of like -8 doesn't mean you just write -8. Find it for real. Don't mark the points of inflection as extrema. Plus or minus infinity don't count as extrema, because you can't turn at infinity. It's not a location. Okay, any of those things that you need to write, to make it make sense for you so you don't get caught in the trap. Okay? Round 2. The change along a specified interval, average rate of change, is effectively slope. See, we already know the whole x2 minus x1 thing. It's just now we write it a little bit fancier and say the function of x sub 2 minus the function of x sub 1. Now remember, the function of that value is to give me the y that goes with it. F of x is not just a fancy y, but they are referring to the same thing. So, I use parentheses so I don't screw up negatives. And then, I know x sub 1, x sub 2. To get the y sub 2 and y sub 1 that go with them, plug them in. Plug a 3 in here. 27 minus 21, 6 minus 4 is 2. 1, well, cubed is 1. Minus 7 is negative 6, minus 4 is negative 10. Getting 12 over 2, getting 6. Okay. It's not in my instructions here. How do I know if this is an interval of increase or decrease? Positive or negative, pretty straightforward, right? What are some notes? Use parentheses. How many times back in Algebra 1 did you get caught in that trap? It's minus a negative 10. Kid after kid, year after year, for generations and eons, says, well, they just put the negative there for me. You're so nice. Y'all, math ain't nice. Math and science don't care what your belief is. It's still going to do the thing. So, minus 10 is supposed to be minus negative 10. Maybe you better follow the actual protocol for it. Throw some parentheses on there so you don't screw that up. Okay. Who's your daddy? Okay. Find the parent function. Yes, go. And close my door while you're at it. Okay. Thankfully, Apple and Capers are pretty good about that. Yeah. They keep all the annoyance out of here. That's my parent function. Normally, the parent function of a cubic looky like this instead. So, I moved that thing left 2, down 3. I'm not just going to say left 2 and down 3 because that's childish. We're going to use our big kid words. We say it's a horizontal translation, left 2 units, and it's a vertical translation, down 3 units. What else? Okay, because a cubic is symmetric to the origin, you could actually reflect either vertically or horizontally and end up with the same thing. But if you come along and say exactly that, in this case you could say x or y, just got one off. Do we remember why?
You have to do this. Yeah, you either have to put or you put
There it is. Okay, we talked about this, where the wording and the order matters. It's not just semantics. If I'm going to say reflection in the axis, I need to say it first. Because otherwise, if I were to translate and then reflect in the y-axis, well, that'd throw it back over here in quadrant 4. If I would say reflect in the x-axis, that'd throw it up here in quadrant 2. Okay, so if I'm going to say it at the end, I can just say a vertical or horizontal, specifically because it was a odd function. Reflection. Okay, so if I'm not saying it first, I'll just say it was a vertical reflection. Or in this specific instance, horizontal reflection. Okay, I could use either one of those. Or, if I'm going to say reflection in the x or y axis, I say it first. I can get real proper, tip the hat, and say reflect with respect to the x or y axis. Again, this one is x or y axis specifically because it was an odd function, which means a vertical reflection results in the same thing as a horizontal reflection. And then I would say it's a horizontal translation left 2, it's a vertical translation down 3. Okay, so either you use the words vertical or horizontal reflection, you don't mention the axis, you can say that whenever, or if you say reflection in whatever axis, you have to say that part first. We made a pretty big deal about that, so hopefully we don't goof that. Okay, backside. Graphing piecewise functions. We said, we seemed pretty good with these. It was just a matter of I need to graph them in their entirety most of the time. And then after that, I'll erase the parts that don't matter. So, when I see absolute value, I know it's a v. When I see square root, I know it's I don't even know what you would call that, errant rocket. I see a negative in the A spot, vertical reflection. +4 in bass-ackwards land grouped with the X, left 4. +5 in the K spot outside of the grouping, up 5. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. Please use points and a straight edge so it doesn't look trash like this. That's where the graph is, but where's the only place I actually care about it? -7 to 0, watch your open and close circles. At -7, I will have an open circle all the way until 5. Down, I want to actually hit my points here, until 0, close circle. And I erase the parts that don't matter. Okay. Not equal to, open circle, equal to, close circle. Then I go and graph the other one. Contestant 2 says, vertical translation up 1 of this little errant rocket here. We're going to go 1, up 2 over 4, up 3 over 9, and whoop, looking like this. And then I come along and say, I only care about it from 0 to 9. So I'll put an open circle here closed circle here, and I'll get rid of everything else that doesn't matter. If you have this on your paper, I'm cool with it. But technically, remember when I said just because you see a piecewise function, don't assume it's jump discontinuity? One rule ended where the other began. I have an open circle with a closed circle in the middle of it. So it's continuous at that point. I could instead have that as a graph. Okay. I could just have that as my graph. But if you have the open circle filled in, if you put the donut hole in the middle of the donut, you said it exists there, so you're good to go. Okay? What's some notes? You could tell yourself how to do it.
One to use an open or closed circle.
Okay? Less ink here, less ink there. More ink here, more ink there. That's a good way to remember whether it's solid or dotted lines, open or closed circles. Maybe your transformation holy grail form. I mean, you use it to graph things. All right. Then, function stuff. F minus g and f divided by g. If I take f, which is 1 over x minus 3, if I take f, which is 1 over x minus 3, g is x squared minus 9, g, x squared minus 9, g, g minus okay. Round one. Distribute my negative. Put it in the correct order. Negative x squared plus 9 plus 1 over x minus 3. Y'all remember doing long and synthetic division? Didn't you always put the remainder at the end like that? Okay. So I'm cool with you leaving it like this because that is the partial fraction decomposition of it. We'll actually do decompositions in chapter 6. If you're feeling frisky, you could take this times x minus 3 over x minus 3. Take this times x minus 3 over x minus 3 to get negative x cubed plus 3x squared plus 9x minus 27 minus 26 all over x minus 3. Y'all remember common denominators with rational expressions? Okay. So if you're feeling real frisky, you can go to Greentown over there. Not necessary. I won't make you do that. In either case, my domain. Y'all, quiz number 1, the number of you who did the simplified radical form of number 5, but didn't do the simplified exponential form. 2 points off. What's 2 points off out of 30? Okay, that's 6.7%. You just dropped yourself down to an automatic 93 or lower, assuming you did everything else perfectly, just by not reading and following the directions. Don't get caught in the trap. Remind yourself, state the domains of each. Okay? The only one not allowed to this party, the only thing that's going to break math law is thou shalt not divide by 0. Rule number 1. So my domain is negative infinity to 3, can't touch this, and 3 to infinity. Okay? It's the only one not allowed. Round 2. It's called a compound fraction. You've been working with them since algebra half, but we get scared every time we see them because we forget that little rhyme from middle school. Dividing by fractions is easy as pie. Flip the second. And multiply. Okay. And this, multiplying fractions, is just numerator times numerator, denominator times denominator. Just distribute. X cubed minus 3x squared minus 9x plus 27. Okay. And then domain. Who's not allowed to that party? Can't divide by 0. So set your denominator equal to 0. Thankfully, I already had it factored back here. Plus or minus 3. We all catch that this is x plus 3, x minus 3, difference of squares. So x is not allowed to be plus or minus 3. To exclude that, we get double union. Negative infinity to negative 3, can't touch it. Negative 3 to 3, can't touch that. And 3 to infinity. Okay. You set the denominator equal to 0. Anything that will make the denominator 0, anything that will violate my rules, anything that's going to eat my goldfish, not allowed to the party. Okay. Write notes to yourself. Remind yourself. Your commandment's a domain. Don't divide by 0. No even roots of negatives. Logarithms, we'll hit those again in chapter 3. And the last one was do all that stuff again, but now it's compositions. So I'm going to bring these guys with me. Okay, find f of g. The purpose of f of a thing is to take 1 over the thing minus 3. That thing happens to be g of x. And g of x is x squared minus 9. So I'll combine like terms and call it 1 over x squared minus 12. Thou shalt not divide by 0. So if I'm not supposed to divide by 0, I'll set my denominator equal to 0 and solve. Making sure to simplify my radical. Okay. Now, this was, maybe I didn't say it well enough in class. Maybe I didn't explicitly highlight this. When I find a composition, part of the composition is stating the restrictions. This is my composition so long as who's not allowed. Okay. So it's not just green. My final answer is green such that x does not equal plus or minus 2 root of 3. So write that next to 6. Part of saying the composition rule is stating not the domain, but the restrictions to the domain. So if you said negative infinity to negative 2 root of 3, negative 2 root of 3 to 2 root of 3, 2 root of 3 to infinity, if you wrote out the entire domain, I'd take it. But part of writing a composition rule is telling you the restrictions. Remember we did this with, it was, what was it, like the parabola with the radical? And we just said, blah, blah, blah parabola such that x is greater than or equal to 1. Okay? And that's going to help us getting into inverses. So part of writing a composition rule is telling me the restriction to the domain. F of g of 3, or sorry, f of g and now g of f. There we go. G rule says the purpose of g is to subtract 9 from the square of a thing. That thing is going to be f of x, which is 1 over x minus 3. When you square a fraction, square numerator and denominator, just not like a freshman. 1 over x cubed minus 6x squared, squared x plus 9, there we go, minus 9. Again, if you want to get common denominators and write it as an entire rational single term, you can. I'm not going to make you. With this, if I look at my denominator, I see that 3 is not allowed. I say x cannot be 3. Did we check? Have we done it? Yes or no? Did we also check the input functions? Okay, the total restrictiveness of my domain. I check the after party and say those guys ain't allowed. I check the before party and say, okay, everyone was allowed in. I check the after party. X can't be 3. I check the original party. X can't be 3. Okay, 3 just really wasn't allowed. That is my restriction. Okay? So, got notes written to yourself. You know what you're going to be doing. What's up? Oh, there's another part. F of g of 3, I have a choice. I can do the chain. Throw 3 into g. 3 squared is 9. 9 minus 9 is 0. Take 0, throw it into f. And get negative 1/3. Option 2. I've got the function rule for f of g. I could just put a negative 3 right there. Negative 3 squared is 9. 9 minus 12 is negative 3. Negative 1/3. In either case, I need to check that 3 was even allowed. Check your restrictions to make sure it's even allowed. Because remember, we run across a couple of problems like that where it looked like, I don't know, it just come out as a linear or simple quadratic for the function rule. And I said, go find f of g of 2, but it turns out 2 wasn't allowed. Okay? So be careful with it. I mean, if you're wondering, like, points-wise how that goes, it's you got the rule, you got the domain, you got the rule, you got the domain, you plug stuff in. I am going to go back, and let's say back here, you accidentally wrote +9. Does your rule still say x squared plus 6? Did you still have all real numbers? Because in that case, there would be no real exemptions to the rule. I would come back here, mark 1 off here, and you'd be good to go because you did what was right based on incorrect information. That goes for the entire thing. Just because you can do something in your head or you can do the whole thing on your calculator doesn't mean you should. Write it out. Because it really sucks when you know what you're doing and you just typed it on a calculator, wrote down 5, and nothing else. Turns out you missed a single parenthesis, or you typed the negative button instead of the minus button. And now the whole thing is wrong. You have no work to back it up. That was worth 5 points out of 30. You just dropped it to a maximum of 83%. Because you got it wrong and you didn't have any work to back it up. So please, write out your thinking, even if you're just typing stuff in a calculator, write out what you're typing. That way I can give you credit when you're still doing stuff right. Okay? Phones. Phones, watches, devices, spy cameras, cyborg implants. Don't take out cyborg implants. That'd be painful. And I have to make that caveat because Lars tried ripping out his pump as a joke last semester. So, y'all got that?